Welcome to another amazing video on trigonometry. This time we're going to tackle a pretty tough topic over inverse trigonometric functions. So let's get right into it. But first we got to remind ourselves what an inverse function is. So in mathematics, an inverse function is a function that serves to undo another function. That is, if f of x produces y, then putting y into the inverse of f would produce the output x. Now remember, the notation we used for an inverse function is this little -1 after the f to indicate that we have an inverse function. So in an inverse function, we're simply switching our x's and y's. It's really that simple. So in a regular function, x goes in, produces a y. If we flip around those values, then we have what we call an inverse function. But there is one really important rule, which is actually what's going to make this video kind of complicated, is that a function f of x has an inverse function only if for every y in its range, there is only one value of x in its domain for which f of x equals y. So the definition of a function is that every x can only produce one and only one y. Okay, everybody kind of knows that. You are allowed to have multiple y's. That is totally fine. The functions are allowed to have different x values take you to different y values or to the same y value. That's fine. But for an inverse to occur, that actually cannot happen. That cannot happen, if that makes sense. For example, let's deal with a quadratic function, very simple quadratic function x squared. Everybody knows that you could plug in 2 and you get 4, but you could also plug in -2. Well, that's not a -2. Sorry about that. You could plug in a -2 and you also get +4. That doesn't violate the fact that we have a function here. Plug in 2, you get an output of 4. Plug in -2, you get an output of 4. You're allowed to have outputs that repeat themselves. Totally fine. But a function like this one that I'm talking about right now does not have an inverse function. It can't, because we violate the rule of an inverse function. Again, for every y in its range, there can only have one x value in its domain. So we literally have proven this right here. We have a y value, 4, that's an output in the range, but it could stem from 2 different x values. And the exact same problem also happens with trigonometric functions. So it kind of means that we don't have inverse trig functions, but we also kind of do if we do a couple special things that we're going to talk about in this video. So that last part is a little bit of the issue that we definitely have to clarify here. So this is our quick remembrance of trig functions. Don't want you guys to forget what they are. With the trigonometric functions, the input is an angle and the output is some defined value based on x, y, and r. So in every one of these trig functions, the input is an angle, but the output is some relationship between x, y, and r. We already know all those and love those. All right, great. Let's dive a little bit into sine specifically. So here we see that sine of an angle equals 0.347, right? Okay, cool. We could even say that we're on the unit circle by just doing that, right? So y is 0.347, my radius is 1, and obviously I could find x if I wanted to, but okay, we're getting a little bit off topic here. So because I put it over 1, I could claim I'm on the unit circle. This is awesome. So I'm trying to figure out what angle would produce this y value. But a couple things I notice, or a couple things you should notice and remember. So first off, a y value of 0.347, if we're on the unit circle, this right here is 0, 1. So a y value of 0.347 would occur somewhere right around here. And this is where we realize we have our problem, because here is a point, here is an angle that would have that corresponding y value of 0.347. Not really worried about x right now because it doesn't say anything about x. We're dealing with sine. But here is another angle right here. We'll call that one theta as well. That also has a y value of 0.347. So just looking at this picture from 0 to 360 degrees or 0 to 2 pi, I actually have 2 different angles that could produce the same outcome of a y value of 0.347. And furthermore, I actually have infinite answers, right? Hopefully you understand that, because I could also go backwards. Right there would be a negative angle that also ends at a spot that has a y value of 0.347. Or I could even go around and around and around and around and stop right here. That would be another angle that has the y value of 0.347. So the first bit of trickery that's going on here is that this angle right here, this input value that is an angle, technically there's infinite answers. There's infinite amount of values for that angle that would produce a y value of 0.347 on the unit circle. I literally made a picture of these two places. Here's one of them and here's one of them. So it looks like there's two of these values, but when you consider the fact that there are an infinite number of angles that could take me to any one of those two values, then it's like I have double infinity, because I got an infinite amount of values that could take me to this angle right here. I got another infinite amount of values that could take me to this angle or this terminal side right there. And at the end of the day, I got too many values. So how the heck do I figure this out? Well, it's tricky. First, we do this. First, we say, all right, how do you actually go ahead and find an inverse? Well, remember, to find an inverse, hopefully you remember, to find an inverse function, the first step is to switch your x's and y's. Well, actually, the first step, I say, is to change the f of x to a y, because f of x is just a fancy way of saying y. Okay, so f of x becomes y, and then we have sine of x. Now, please remember that this right here is an angle. Yeah, I'm calling it x, but I could put anything there, right? We typically do put a theta there, but you could call it anything you want. We just use theta because it's fun and it honors the Greeks. But the point is that that is an angle. That's what I care that you understand most. And the output, whether I call it f of x or y, whatever you want to call it, is the y divided by the radius, or if you're on a unit circle, that would just be y divided by 1, or just y. Okay, great. So I want to switch those two things. Okay, I can switch those two things. So here is x, here is y. So now my angle is over here, my ratio of the y divided by the r, or my output value, is over here. Okay, well, I can't just switch them. Now I have to actually solve for y. That's the next step to finding an inverse. Step 1, change the f of x to y. Step 2, switch your x's and y's, and now I have to solve for that new y. Well, how do I get this y back to over here mathematically? Well, that's where an inverse comes in, right? If it was a square, you could do a square root. If it was a plus, you could do a minus. Well, what do you do with the sign? We'll use an inverse sign. So it's actually easy. So to solve for that y, we need an inverse sign. Now, an inverse sign is literally just SIN, our same abbreviation for sine, but we put this little -1 right there to again represent that that's a inverse. That does not mean an exponent. That's not an exponent of -1 or anything like that. It's our indication that we have an inverse sign. Now, what's more important is that you understand that when you're working with an inverse sign, the output is now my angle, because remember, inputs and outputs switch. And the input right there is the ratio of the y divided by the r from a circle in standard position, all that fun stuff. So what goes into an inverse sign is that ratio of y over r. What comes out is the angle. But the problem that I'm trying to address here is that, if we go back to the original function, there are many, many, many angles that would lead me to the same output. In fact, there's not just many of them, there's infinite of them. So if I reverse that, now I violate the definition of a function, because in this inverse function, if I plug in a ratio, y divided by r, there are infinite angles that could lead me to that. And again, that's actually what I was trying to prove to you here. So watch this. If I come back here for a second and I say, okay, I want to solve for the angle. I want to know what that angle is. I want to solve for it. Well, we would use an inverse, because that's how I could switch my input with my output. So I'd use an inverse sign, and the 0.347 would go into that, and out would come my angle. So again, remember, I'm just taking the output, and it's now being used as my input. It does not change that the 0.347 represents the y-coordinate from the unit circle, and my theta is what I'm trying to equal. But again, if this is going to be dubbed a function, I'm only allowed to have one output, which means I'm only allowed to have one angle. But we all know that there's infinite angles. So what we do to fix this problem is we adjust the definition of the inverse. So we say, okay, to get one and only one angle, I have to only look at the right side of the graph. Because on the right side of the graph, my y values, which is what sine represents from the unit circle, my y values do not repeat themselves. Every y value on the right-hand side is positive if you're in quadrant 1, negative if you're in quadrant 4. So it takes this value right here that was a repeat. It also had the same output value of 0.347, and it eliminates it from even being possible, because that would be a second answer for theta, and I'm not allowed second answers when it comes to functions. I know it's getting a little bit confusing, so I might want to watch this video a couple times. So if I'm going to actually solve for theta, I have to limit myself. Now, again, this is where you have to understand, truthfully, there are infinite answers to this, infinite. But if I'm going to use the inverse sign to solve for this angle, I have to limit myself to any angle in this first quadrant and fourth quadrant. So technically, that would actually be any angle from negative 90 degrees to positive 90 degrees. So I'm only allowed to look up to 90 or down to negative 90, because values over here have different y values. They won't repeat themselves. And again, furthermore, I'm actually limiting myself. I'm not allowed to go around and around and around and around and around. Okay, so I know this might be getting very confusing, and I apologize for that. I'm just trying my absolute best here to explain this to you. But I can't have multiple answers if I'm going to call myself a function. It's just not allowed, right? For the same input. One input can only produce one output. So to allow that to happen with these inverse functions, the function itself can only give me one answer that either goes up to 90 degrees or down to negative 90 degrees. All right, so how am I going to get this answer? That's probably what you've been waiting for. First, I do need my calculator. I need to make sure that the mode I'm in matters, so I'm only going to get what I asked for. So if I'm looking for an answer in degrees, I am going to need to put myself in degree mode. But we could also get the answer in radians. It would just be the equivalent degree, but I want degrees right now, so put my calculator in degree mode. Then what I'm going to do is I'm going to get the inverse sine function. That can actually be found by right above sine is the inverse sine. So second sine brings up that inverse sine, that little negative one right there. Again, does not mean an exponent. It's the inverse. And I'm going to type in 0.347. Now the calculator is going to give me one and only one answer. But I know technically there are infinite answers to the problem. But the calculator, knowing that I'm only allowed to work with functions, which by definition can only have one output, it's only going to give me one output of 20.304 degrees. So that is the green angle. I know this is, you know what, let me kind of refresh this a little bit here. Getting really, really messy. Sorry about that. Okay, so once again, if I understand that a y value of 0.347 is right around here, that's where my y value is 0.347. That angle right there, I just found out to be 20.304 degrees. So there is my angle. That's it right there. I just drew it. It's perfect, right? It's gorgeous. But you have to know there's actually technically infinite more answers, because if I take 20.304 degrees and I add a full circle, that would be the angle that goes all the way around 360 and then the additional 20 degrees. That would be another angle that has that same y value of 0.347. Again, it's another angle. It's another one. But the calculator can't give me more than two angles because it's only allowed to have that one output. And I also know, again, as I drew earlier, that there is actually another angle over here. There is another angle over here. And that angle, let me use blue to draw it here, that angle would go like this. That angle does exist, but the calculator couldn't give me that angle because the calculator is only allowed to give me one output, because that's all sine's allowed to give me. Inverse sine, because again, you can only have one output. So I could still find this blue angle, but the calculator's not going to give it to me. I have to think about it. And that's where it's not very hard. You just got to think about reference angles. If this angle right here is 20.304 degrees, so is this angle right here. That means if I take 180 degrees, a half a circle, and I subtract the 20.304 degrees, I will get that blue angle that, guess what, also has a y value of 0.347. So I'm going to have to do a little bit of math there. 180 minus the 20.304 degrees, and I get 159.696. So that blue angle is 169 point, I forget what it was already, 159.696. 159.696 degrees. And the cool thing is you could actually check your work by using regular sine. So sine of 20.304 degrees. Now this is regular sine, not inverse sine. So angle goes in, y value comes out. Check out the y value, 0.347. Oh my gosh, we knew that. Obviously, there's a couple extra decimals there because I rounded. And then we could also do the sine of the 159.696 degrees. Oh my gosh, y value, 0.347. Unbelievable. We could even do sine of the 20.304 plus 360, right? Because that would just be taking the original angle and going around a full circle. It's going to take me right back to the same y value. So again, there are infinite angles that have a y-coordinate of 0.347, but if I'm going to use an inverse to help me solve for that angle, I have to understand that the calculator can only give me one and only one angle. I know there's more, but the calculator can only give me one. So the calculator is going to give you an angle that is, again, is either going to go up to 90 degrees or down to negative 90 degrees. All right, let's look at another example here just to see if it all is hitting home. All right, so sine of an angle is negative 0.087. You could put that over 1 and say y over r to ensure that we are on the unit circle here. All right, so where is an angle? That's my input with sine. That produces an output of negative 0.87. Okay, well, a y value is negative somewhere down in either quadrant 3 or quadrant 4. And I'm looking for negative 0.87. So down here is 0, negative 1. So negative 0.87 is going to be somewhere right around here. So I'm thinking there are a couple angles. There's this angle right here that goes all the way around to there. That would have a y value of negative 0.87. And there's also this angle that's going to be over here in quadrant 4. And I would have to go all the way around. That would produce a y value of negative 0.87. Okay, great. But again, those aren't even the only two angles because I can keep adding 360 and adding 360 to either one of these thetas, and I would get more and more and more answers. Okay, so how do I get these values? How do I solve? How do I find the inverse? Well, again, first, to actually solve, I'm going to need my inverse function. That is going to switch my input and my output. So now my input is the y divided by r, or y over 1, since I'm on the unit circle, negative 0.87, equaling my output is now the angle. Okay, this is awesome. This is great. But when I go to my calculator, make sure you're in degree mode. I should still be in degree mode. And then when I go and actually do this math, inverse sine of negative 0.87, I get negative 60.459 degrees. Let me write that down real quick. Negative 60 point, I forget already, I got a terrible memory, 459 degrees. Okay, so that is the green angle. Oh, but actually it's not. It is the green angle, but it's the angle that goes down to get there. That's the negative 0.459 degrees. Because remember, it's an inverse, and it's an inverse function. And to be a function, there's only allowed to be one output. And what sine inverse does is it specifically defines its outputs to be anywhere from positive 90 to negative 90. It's only allowed to look at that right side because on that right side, y values, that sine, do not repeat themselves. Every y value on the right-hand side in quadrant 1 and quadrant 4 don't repeat themselves as long as you stay in that range. You're not allowed to go around the circle. You're not allowed to go multiple times forward or backwards. You're only allowed to go up to 90 or down to negative 90. So that's why they gave me the answer of negative 60.459. But I know that there, again, are infinite more answers that would produce the same output value of negative 0.874 sine. That's the only one that's allowed to give me. I mean, that is the answer. I'm not trying to take back the fact that that's the answer, but that's the only one it's allowed to give me, because if it gave me a different one, well, then that would mean it's giving me multiple outputs, and functions are only allowed to have one and only one output for each input. So this is where we say we just have to define the inverse of sine to only exist from negative 90 degrees for our outputs to positive 90 degrees. Well, yeah, so you get the point. So again, that's my answer. Like, I'm not trying to say this isn't my answer. Obviously it is, right? And again, check your work on your calculator. Sine of negative 60.459 degrees is, oh, boom, negative 0.87. A little bit off because I rounded, but essentially negative 0.87, right? All right, but what about the angles I drew? Well, if I want to find the angles I drew, I'm going to have to do a little bit of thinking. The green angle I drew that goes all the way through quadrant 1, quadrant 2, quadrant 3, and into quadrant 4, I can find by taking 360 degrees and subtracting the 60.459 degrees. Because if I take the full circle, 360, get rid of that angle that I just found, the 60.459 negative, I will get that green angle. What about the red angle? Well, I have to think symmetry here. If this angle right here is the 60.459 degrees, so is this angle right here, symmetry. So if I take 180 degrees and I add the 60.459 degrees, I will actually get that red angle that stops in quadrant 3. So go to the calculator, 360 minus the 60.459 degrees. That gets me that green angle. And 180 plus the 60. And again, the picture really does help. So drawing that picture is worth 1,000 words, man. So 459, sorry about that, 459. That's going to give me my other angle. Now, neither of those angles is what the calculator actually gave me, because I had the common sense to understand what the calculator gave me. The calculator is only allowed to give me one answer because it's a function. I know that there are actually infinite more. I just found 2 of them. There's infinite more. And you can always check your work by doing sine of 299, extra on there, 0.451. Oh boy, I really messed that up. Let's do that again here. It's hard using this calculator. 541. Hey, negative 0.87. What do you know? Sine of the 240, 0.459. Hey, what do you know? Negative 0.8700. Okay, you get it. That's how I find these values. Okay? So, at the end of the day, how do we fix the problem? First, you find the inverse function. Then we have to define it in a specific way where each input will only produce one output. So our inverse function for sine looks like this. It's beautiful. It's awesome. Understand that here inputs are y over r. Outputs over here are angles, because an inverse literally switches what we used to think of input and output. Sine, input angle, output y over r, but now we're switching that because it's an inverse. But to allow there to only be one and only one solution, because that's all you're allowed with a function, we specifically have to define that the angle that we can find, the output, which we can call y, has to be between negative 90 degrees and positive 90 degrees, or if in radian mode, that would be pi over 2, negative pi over 2, and positive pi over 2. So that's that right-hand side of the graph, because on that right-hand side of the graph, up 90 degrees, down negative 90 degrees, y values do not repeat themselves. Okay, that's it. Stay tuned for another, hopefully much shorter video that goes over cosine inverse, and then another one for tangent inverse. Those videos will be a lot shorter because I can just dive right into the ins and outs of it, because hopefully you understand the concepts here as to why these functions exist, how they help us find angles. but how the calculator only gives us certain angles, certain answers we got to be very careful with. All right, see you later. Hopefully this video wasn't too bad. I know it's not the easiest of topics.